When I started 3D printing car parts, I thought I found the perfect budget 3D printer, an Ender 3 for only $289. But I quickly learned that I wasn't going to be able to print higher end filaments with the Ender 3. So I started to lose hope, but after some more searching is when I found another budget 3D printer, the Centauri Carbon. It's an enclosed 3D printer for only $30 more than the Ender 3. Now, having an enclosure is pretty important when 3D printing your car parts, which I'll cover in a few, but the Centauri Carbon also comes with hardened steel parts, meaning that we'll be able to print with better filaments that are even fiber and glass infused. Now, if you're going to want to print reliable car parts, you're gonna need filament that can handle the hot sun, as well as filament that has UV resistance. You also want something that's water resistant if you plan on making external parts too. And the material that gives us all three of these is ASA filament. Its heat deflection temp is around 212 degrees Fahrenheit, making it perfect for parts that'll be in the dash. And it also comes in different colors like black, red, even blue. But since ASA has higher heat resistance, you're gonna have to print it nice and warm. And that's where the Ender 3 completely failed and where the enclosure comes into play. The removable glass top and door help keep the heat created by the build plate inside the printer. And the walls surrounding the printer will also slow down the heat from escaping too. Now, the Centauri Carbon also has a camera at the top corner of the printer to help you see how your prints are doing. But with a budget setup like this, it doesn't necessarily detect if something's failed during the print. You'd have to be watching that yourself. However, there is a way to fix that. And that's what software called Octo Everywhere. It's supported on the Centauri Carbon and allows you to view stats from your printer remotely. It can even be installed on a Raspberry Pi or directly on your computer using a Docker container. The directions are pretty easy to follow, and once you have it installed, you can launch the web app. It also comes with an AI feature detection by using the camera to find any issues during the print. The free version can notify you, and they also have a low-cost paid option for pausing the print as well. The free version lets you connect from the web or mobile app, and you can control the features of the printer and pull up the camera remotely. But this isn't the only advantage of the Centauri Carbon. One other advantage that the Centauri Carbon has over lower cost 3D printers like the Ender 3 is it has a fixed bed, meaning that the bed only moves up and down versus slinging back and forth. And the hot end does most of the work by going left to right and front to back. So this helps reduce the vibrations and keeps the enclosure a lot smaller. So one thing I hated with the Ender 3 was all the manual calibration process, like leveling the bed and setting the Z offset, but the Centauri Carbon does have auto calibration features, so let's take a look at them. Its calibration takes care of bed leveling, heat variance, vibration compensation, and has a one-check self-test. The bed leveling also takes into account what type of build plate you're using. The input shaping will also help with shakes and vibrations, and the PID tuning will make sure that the heat fluctuation is set properly. The calibration should be ran right after unboxing the printer, moving it, changing, or doing maintenance. And before printing your first car part, there's another super important thing you should do. You'll notice that when you take your new filament out of the box, it's wrapped and includes moisture beads. This helps prevent moisture absorbing into your filament. We'll also need to make sure that we dry our filament, so I picked up this filament dryer for only $30. The filament will have to be heated up for about 8 hours at 170-ish degrees Fahrenheit. Now don't worry, we'll put all of the parts in the video description below. The filament dryer is pretty easy to load and has a quick selection for which filament you're trying to dry, but we'll need around 1 to 2 hours added to the 8 hours, as this dryer can only get up to around 150-ish degrees Fahrenheit. The filament dryer can also run while the printer is printing, and while the filament is drying, we're going to prep our car part design. We're using the Include Elegoo Slicer software connected via Wi-Fi, and we're going to start with a couple of delete plates that I designed, and we can drop right into the build plate and clone. And if you want to learn how to design your own parts, I have a full workshop I'll also leave in the description below. Printing 4 of these will only take around 20 minutes, and if you don't use Octo Everywhere, you can just view the videos straight from the device page.
Ooh. So the print is severely warped, and here you can see that the part is curved and half the print stayed on the bed and the other started to peel up, and the hot end started to smash into this clip here. So I was afraid that this might happen because it's around 50-ish degrees Fahrenheit in the garage right now. So what may be happening is that it's not getting hot enough inside the chamber as we're printing this part. But I think there's a couple of things that we can do to tweak the settings to make this come out just right.
To make changes, we can open up the base ASA filament profile, and I'm just going to make sure that I have all the fans set off. I'm also going to crank up the bed temp to the max of 110 Celsius. Now the printer doesn't have a heated chamber, so we're just going to make sure that the bed stays on to heat up the inside of the printer before we start printing for around 20 minutes. Then I'm going to save this profile and create a new name. That way I'll know what settings have been changed based on this name.
All right, here's round 2. So I put the little mini delete plates on top of the glass here to show you how flat they are. Okay, so if we take a look close up, we can see that the clips came out flawless. So letting the printer warm up first, especially if it's really cold where you're printing, is gonna make a huge difference printing these higher end filaments. So you're definitely going to want to tweak those settings as well as turn all the additional fans off.
So I'm going to try something bigger, a custom radio delete plate design, which we also cover how to make in the workshop. And for larger parts, there's one more thing we can do to help prevent warping. Just search for a feature called brim. It's essentially one layer that prints around the outer and inner perimeter of the part. This gives more surface area attached to the bed, helping the print from warping. Here you can see that the print has tons of surface area on the build plate, and now we can send it off to the printer.
So this next part came out amazing. Take a look at that. So a flatter part seemed to work flawless with our trick, but what if we tried something much wider and even taller, plus with filament that can even handle engine bay temps?
For this next part, we'll be using PA6 CF filament, nylon with carbon fiber, that has a heat deflection temp of around 330 degrees Fahrenheit. And because it loves to absorb moisture, I left it in the filament dryer for over 13 hours. Our next 3D printed car part is an air intake adapter that I reverse engineered and added a curve to make space for a new cold air intake filter on the E30 build. I started with the generic PA6 CF profile and used the same higher preheated bed and no fan method used on the ASA printed car parts. I also added a thick brim to help hold down the part through the entire print.
So here is the part. Take a look at that. It looks amazing. The part is really, really strong, and you can hardly see the layer lines. And the PA6 CF is going to have no issues in the engine bay of our E30 project car. And I don't know, tell me, what do you think? For a budget $300 printer, I mean, you really can't beat this. So if you're interested in how to do more 3D printing and designing car parts, watch this video up next here.